Hi. This is called as the demand side management object function for our code, and the program will optimize this function to get the lower value of the cost of the generation. And in all the other cases, this function is changing for all the other cases. So the change will be here in the our all cases. So the first thing is to initial some parameters like the solar generation profile and solar generation and wind generation, load for 24 hours, market price for 24 hours, that read it from all the MATLAB functions. And after that we also define the price of the microturbine, fuel cell and batteries and other utilities. Here we define that, and after that we also define started the program of dispatch, the unit commitment here, as you see here from the optimization variables we decide or the unit commitment, and the dispatch also from the optimization parameter, and then the battery storage. And after that, after to read it the value of megawatt or the status of generation from the optimization parameters or variables that input in from the optimization function, and after that we applied some limits and constraint on the dispatch and unit commitment and batteries. The first thing is the constraint of the batteries, that the energy from the batteries should be, as you see here, the energy is should be not less than or not exceeded the 700, and the battery storage in this case, if the battery storage is less than zeros and the energy from stored in the battery is less than 700, so the charging mode is started, and else we go to the discharging mode. So the first thing is to apply where is the battery storage, is the charging mode or discharging mode. If it is negative or and the energy stored in the battery is less than 700, so we go to the charging mode, and the battery will be charged from the amount of that values that optimize the function. And as you see here, also changing the size of the battery. And after that, if this function is not occurred, so then we also go to the else if battery is less than but exceeded the limit of energy, so the battery storage will be 0 here, and the constraint here applied on that megawatt from the batteries. But also we have another cases. So if the battery storage is positive and the energy will equal 0, and also the energy stored in the battery storage is 0, so the battery storage will apply the constraints on that battery storage and equal to 0. The last cases of the battery here is to discharging mode. If not any cases here occurred or any condition corrected here or defined, the discharge mode will be occur here, and discharge the battery storage, and negative the battery storage, or subtract the energy from the battery from the stored energy, and repeated that for 24 hours. So we have 4 cases for the batteries. The first thing, if the battery is less than the zeros and the energy stored less than 700, we are in charging mode. If the battery storage in less than less than 0, but the energy stored in the battery is more than 700, so we are in idle mode. And the next case is the third case is also idle mode. If the battery storage is more than zeros and the energy stored in the battery is equal 0, so we are in idle mode also. And if not occur the three cases before, so we are in discharging mode. And this is the battery storage model here, and the applied constraint of the battery storage. And after that, after we apply the constraint of the battery storage and some limited from the battery storage, we are now in the balancing mode. The balancing mode, we have the load, we have the PV, we have the wind, we have distributed generation, multiply the unit commitment, distributed sources with the unit commitment, and the next thing is the battery storage. The balancing is to load minus the generation, as you see here, generation, and the PV take it as it is, and the wind also the same thing. And after that, we go to the first in the micro turbine multiplied by unit status of micro turbine, and generation from the fuel cell, and multiply by the status of fuel cell, and then subtract the battery megawatt. And after that, compare that to get the utility, as you see here, utility megawatt. And the utility, as we have constrained, it's not exceeded 30 megawatts imported or exported, as you see here. And after that, after we applied this constraint, we calculated, as you see here, the net load. The net load, that means what is the megawatt is still not covered by the PV wind and the generation and utility and battery storage. So the load minus the PV and wind and the fuel cell and the micro turbine, and minus the utilities, and minus the battery storage. If this is if the load is more than the generation, so the net load is positive. If the generation is more than the load, so the net load is negative. And after that, we started to while loop or loop here. If the net load is more than zeros, or the counterpart is less than 4, as you see here, we are still in the while loop, and we repeated the process. The first thing is the case 1. If the net load is positive and the counterpart is less than 4, the counterpart now is 1, so the case 1 is to operate the as you see here, operate the micro turbine. And the case 2 is operate the battery storage. In the third case is operated the fuel cell generation. And after applied case 1, we calculated the net load, and we increased the counterpart, and after calculated battery, the loop is still active. After finish, maybe the net load is equal 0, or the counterpart is exceeded the 4. And after that, also this is for to increasing the power. This is if the net load is positive and the load is more than the generation side. If the load is less than generation side, and that we repeated the other process, the case 1 is decreases the net load from the fuel cell, and the second thing from the battery, the third thing from the micro turbine, and also calculated the net load and counterpart. If the net load is equal 0 or counterpart reach to 4, so the program will go out the loop here. And after that, we calculated the new net load and repeated that for 24 hours. And after finished from the 24 hours, we updated the status of the generation, the megawatt from the generation, and the battery storage also updated here to be output. And after that, we calculated the cost, the startup cost, as you see here, from the generation or micro turbine and fuel cell, and also we calculated the cost the utility cost as a market cost, and the price of the microturbine, price of fuel cell, price of the wind, PV, solar. We calculated the cost and then sum this cost for 24 hours and applied the startup cost also to calculate the total cost. And after that, we calculated the fitness value. The fitness value is dependent on two things. The first thing is the total cost, and the second thing if the net load is not covered. If the load is not covered, so or the generation is more than the load, so we multiply by the factors, that penalty factors. So we have two things. The first thing is the total cost from the generation, and the second thing is the penalty cost if the load is not covered. This is the demand side management object function, how to operate here. This is optimized by the APC program, but in the other case, the demand side management program is different than the base case. We hope this is clear, and if you have any question, you can ask us. And we hope it's clear everything, and thank you very much.